Hello, everybody. This is From Zero to Production with Kubernetes. My name is Josh. I am a solutions architect here at Plumi. With me is Javier Evans. Javier, would you like to introduce yourself to the folks?
Hi, I'm Javier Evans, and I'm a solutions engineer with Nginx, a community alliances team.
Awesome. All right. So, a little bit of housekeeping. So, there's like different tabs that I believe everybody can see. First off, the chat tab. Please be chatty in the chat. If you like something, let us know. That helps us as presenters because it, makes us feel like we're not just kind of speaking into the ether. Yeah. So, do be chatty in the chat. That helps us as presenters. On the Q&A tab, please ask your questions there. This is a pretty highly attended workshop. So if you ask your questions in the Q&A tab, they basically, for us, stay sticky so they don't scroll out of view, so we can make sure that we answer all of your questions. So that's Q&A tab. Also, there are sub tabs within Q&A that let us know like what questions are new and what are already answered. So your question, if you have one and maybe you're joining us late, that might come up in the Q&A tab and it might have already been answered. So check that answered tab, answered like sub tab as well. There's a link to the workshop code on this slide. I will also add it on the handouts tab, but presenting it here for folks that might be watching this on YouTube later on. Speaking of YouTube, also the slides should be on the handouts tab, and I forgot to do that, so I will take care of that in just a few moments. Everyone that is joining us today, you will get a link to the YouTube video of this presentation. That'll come in a follow-up email that'll be from Pulumi, and that'll happen in another day or two. So if you don't catch anything the first time around, you will be able to join us again via YouTube, and you can watch as slow or as fast as you like. And there should be extra Q&A time at the end of this session. And again, the workshop code, you can find that at https github.com/nginx incorporated, INC, kick reference architectures. But also, if you search for like Mara GitHub, you'll find it. I do see that someone is reporting that they cannot hear us. It says no sound. For no sound, either click or tap the screen. I have heard that apparently in some either on phone or something like that you have to either click the screen or something like that. Okay, so moving along. Oh, yes. So, folks, you should have received an invite to a temporary to a Pulumi organization. If you have not accepted that invite, please do so. That will help you create a Pulumi account, which will help you get learning how to use Pulumi in a very convenient way. That organization will exist for a couple of weeks, but you can also create Pulumi stacks in your own personal org as well. So again, if you have not yet accepted this invite, it would be good to do so because it'll help you create a Pulumi account. So let's start with explaining a little bit about Pulumi. What is Pulumi? Well, Pulumi is an open source infrastructure as code tool, and it has two parts. There is the open source infrastructure as code side, and then we also have a free and commercial SaaS that we call Pulumi Cloud. And there's two really important things to understand about Pulumi. One is that it allows you to use general purpose programming languages. So, and I'll get into the full list of languages we support in the next slide. And you can control resources in any cloud. And so that's what makes Pulumi unique among the infrastructure as code toolscape is that, again, it's general purpose programming languages, but you can also use that to control resources in any cloud. Looking at this slide, if we go to the top left, this is the list of languages that Pulumi supports. So we support Node and then both JavaScript and TypeScript on the Node.js platform. We support .NET, so that includes C#, VB, VB.NET even, F#, the JVM languages, Java, Scala, Kotlin, etc. You can also write Pulumi programs using Python or Go, and then we also have an option for YAML. And if you look at the bottom left of this slide, you can see that one of the benefits of writing infrastructure as code using general purpose languages is that you don't need any special tooling and you can use the same IDEs that you're used to. So if you are writing a Pulumi program in Visual Studio Code, You can, IntelliSense is just going to work. You don't need any additional plugins. You can use whatever IDE that you like using today. In addition, if you want to share Plumi code, well, that's just sharing like a regular old PyPI package or an npm package or a NuGet package or whatever. So sharing code is really easy because, again, these are just general purpose programming languages. And so the same tooling also works with those. In addition, when you're writing Pulumi programs, if you want to bring in, let's say you're writing in Python and you want to pull in data from somewhere else via HTTP, well, you can just import the request library and it just works. And also you can also use the same unit testing tooling that you are used to using. All that stuff just works with Pulumi. So that covers the left-hand side of this slide. In the middle, this is kind of where we get into the any cloud part. So Pulumi has providers for all the major hyperscalers, and then a long, long list of smaller cloud providers and SaaS providers like GitHub, GitLab, Datadog, New Relic, etc. And part of the power of Pulumi is that you can use this single infrastructure as code tool to orchestrate resources between multiple clouds, and Pulumi is still going to keep track of all the dependencies for you. A little bit about Pulumi programs. So at the top level, you have a project. You don't really think about projects that much. They kind of appear when you bootstrap a Pulumi program, and they kind of disappear if you delete everything. Within the project, you have the Pulumi program. Pulumi programs in Python, it's the main entry point is __ main.py __ or I flip those underscores, but you get the idea. Whatever language you're using, it's going to be the idiomatic entry point. So if you're writing in TypeScript, it's going to be index.ts. If you're writing in Go, it's main.go, so on and so forth. That's where the program is. Within your program, you are going to declare resources. An example of a resource is like an S3 bucket. Resources have inputs and they have outputs. An example of an input, if you are setting up an S3 bucket, for example, to be like a website, you would like set up like, hey, here's the 404 document, here's the index document. Those are inputs. An example of an output might be the bucket's ARN. And so when you write Pulumi programs, you're going to be using this pattern where one resource's output becomes the input of another resource. And so like, let's say you create an S3 bucket and then you want to add a policy to the bucket. So you need the ARN in order to formulate the policy for the bucket. And so all you need to do in Pulumi programs is declare your desired end state. And because Pulumi uses these inputs and outputs, it's keeping track behind the scenes of what needs to be done and in what order. And that includes, like, for example, if you were to change like the name of a bucket that would cause the policy to need to be recreated, Pulumi will keep track of those dependencies for you. So in this way, Pulumi programs are declarative. Again, all you need to do is say, these are the resources I want with these properties, and Pulumi will figure out what needs to be changed and in what order. So that covers the program on the left-hand side of the slide. On the right-hand side of this slide, we have stacks. Stacks are essentially instances of Pulumi programs. You would use them, for example, to create a dev, QA, and prod environment. Stacks each have their own configuration files. So, for example, let's say you're spinning up EKS clusters. Maybe you want less log retention or maybe no log retention at all. And so you can add configuration values to your stack configuration files and then use those to drive behavior in your Pulumi program. So you could have like, retain logs equals false in a dev QA, in a dev environment. Read that value from your stack configuration file and then skip a whole set of resources in the dev environment. But then you might want that on in the production environment, or you might want more nodes in your cluster or more powerful nodes in your cluster. So like that's how you can use a single Pulumi program to stamp out multiple environments. A little bit about Pulumi's physical model. So in the bottom left-hand corner of the slide, we have our Pulumi program. Today, we're going to be using TypeScript. In simpler usage scenarios, not like what we're going to be presenting today. We're going to be presenting something a little bit more advanced, which I'll explain momentarily. Your Pulumi program is interpreted by the Pulumi engine. The Pulumi engine is essentially doing a diff between the resources that you declare in your Pulumi program. So that's your desired state, and your state file, which we're going to store in the Pulumi service. And it's basically doing a diff between those two things. And it's figuring out what do I need to create in what order to get it into the desired state that is in the Pulumi program. And the way that it does this is via Pulumi providers. So there's like an AWS provider that you might use, for example, to provision an EKS cluster. And there's a Kubernetes provider that you might use if you wanted to, for example, deploy like Nginx onto that cluster. And the part of the power of Pulumi is orchestrating multiple providers in the same program. That's where you're really going to see the productivity benefits that Pulumi has. In addition to this model, what we're going to be showing today with Mara, Pulumi has this feature called the Automation API. And what that does is it essentially flips the dependency so that the Pulumi engine itself is embedded in your program. So normally, if you're running a Pulumi program, you're going to run Pulumi up, for example, to update your infrastructure. But if you're using the Automation API, you're going to embed the Pulumi engine in your program, and your program is going to call Pulumi up via like an SDK. And so you would run that program just by running Python 3, whatever the name of your entry point is. And Javier is going to show this a little bit later, so that hopefully it'll all become clear. Another feature that I really love about Pulumi is we have a policy as code engine. I think it totally rules. So you can write policies in Node.js or Python. Essentially what you're doing is you are writing a validator function. Pulumi will pass you a resource. You can look at the properties on the resource and determine whether or not it complies with your organization's policy. If it does not comply with your organization's policy, there are 3 things you can do. First, you can mark the policy rule as advisory, which will function essentially as a warning. So it'll issue a warning to a user. You can set it as mandatory, which means that your Pulumi operation will fail. So if you are running your policies in a pipeline, your pipeline will stop and the infrastructure will not be deployed. Or we have a new feature that will allow you to remediate the issue in place. So if you're missing a tag and you know from the context what the tag should be, you can simply apply the tag and keep your pipelines moving. So again, I'm talking about pipelines. You can run these policies locally, and your developers will get fast feedback as to what resources are compliant. And then you can also embed those same policies in a CI/CD pipeline so that you get so that you can ensure that only compliant resources are deployed into your environments. Pulumi also came out with a new set of compliance-ready policies. So if you are working in a regulated industry, Pulumi has policies already ready out of the box that will help ensure your compliance with, for example, PCI DSS or ISO 27001. And this works for all the major hyperscalers. And as you can see in the bottom left-hand corner of this slide, essentially the way it works is we give you these compliance-ready policies. You can select the subset of those policy rules that are relevant for you. So in this example, this is creating a policy pack, which is just a set of policy rules. For AWS, that covers the EC2 and S3 services. It's all issues that are medium or higher severity, and it's for like the PCI DSS framework. And so in this way, you can kind of compose your own internal policies from our your own internal policy packs from our compliance-ready policies. So that covers policy as code. This, folks, is 2023, and as you may have heard, AI is a very hot topic. Pulumi has an AI product. It is very useful, as Javier will explain a little bit in detail later. If you go to pulumi.com/AI, it is free to use. It is powered by ChatGPT-4. The way it works is essentially you enter a natural language query. You select the Pulumi language that you would like the output to be in, and Pulumi will generate a program for you. Now, these are LLMs. They are not perfect. They are not perfectly accurate. However, when you use Pulumi AI, you will probably end up with either exactly what you wanted in a best case, but even in a worst case, you have probably about 80% correct starting point. And the way that you can use Pulumi AI is you can go in there, enter the natural language query. Pulumi generates a program. You paste it into your IDE. say, hey, like this isn't working or this isn't exactly what I want. And then Plumi AI will revise the program that it generates. So it's a really, really useful tool. And I highly recommend that folks check it out. There is a link to Plumi AI on the handouts tab if you would like to check it out. And again, it's free to use, and I find it personally very helpful. One more time, I would like folks to create a Plumi account if you have not yet done so. Plumi accounts are free for individual use forever. So I would highly recommend that if you don't have a Plumi account yet, please do create one. So at a basic level, Plumi Cloud will manage your state file and handle secrets encryption and decryption for you. I don't have a slide for this, but it's worth mentioning that Plumi, for example, knows what values are secrets, and it will not store any secrets in plain text in your state file. Likewise, even if you attempt to enter what looks like a password into your stack configuration file, Plumi will detect that and say, hey, I think this is a secret. So you either need to supply the secret flag or tell me to force to store this in plain text. So Plumi has really, really good coverage for security and handles secrets very, very well. So do create a Plumi account if you want to learn Plumi. It is free for individual use forever, and we do not ask you for any payment information. If you are using Plumi for a while, you're getting used to it, you think you might want to adopt it at an organizational level, that's a great time to sign up for a free 14-day trial. So the way that works is you can go into the Plumi Cloud Console, create an organization, and we'll give you full access to all the highest level enterprise features for 14 days, and we still don't ask you for any payment information. So what does that include? Some really cool features like server-side enforcement of policies, single sign-on, SCIM, the whole kit and caboodle, as we say in the States. So you will get full access to all of our features for 2 weeks. And then once again, if you have not yet accepted your invite to join this Plumi org, please do so. You should find this in your inbox. And now I will hand it off to Javier.
Thanks, Josh. Yeah, the AI stuff was definitely a big help for me coming up on some of the features I needed to use in Plumi for this. So we'll get into more of that later. But I'm going to introduce Mara, and then I'm going to walk you through mostly sort of automation API stuff and just how we are using Plumi to, make a very complex code base work. So what is Mara? Well, Mara is coming from this idea that we had at Nginx, where we were talking a lot about the idea of a quote unquote modern application. And a modern application that we were thinking of was an application that is, scalable. It can be moved between clouds. It can respond to changes in how users are using it, or, degradation of the underlying hardware. So basically just a robust application that's not going to fall down and that you can use anywhere and kind of maintain sustainably while still doing important work. And the more we talked about it, we realized that a lot of the things that we desired from this idea of a modern application actually came from underneath. All the layers of monitoring, standing up and working with your cloud infrastructure, observability tooling, alerting tooling, all of that stuff. It's like peeling back the pieces of an onion. You need more and more just to accomplish this simple goal of an application that is scalable and doesn't fall down. So with that in mind, we set out to create a project that is kind of our best shot at saying this is what we would like to have in production to use to support an application or applications that we're running. So who are we to decide that? I mean, we are the Nginx Community and Alliances team, and we're composed of a bunch of people that have a lot of very different industry experience. We have a lot of former operators, platform folks, people like me who come from the development side. And we took that expertise and all those opinions that we formed over those years and kind of put them into Mara to create this example. And why is someone from Nginx here talking to you at a infrastructure as code webinar? Well, I wanted to just kind of take a slight detour from Mara and just note that Mara does have the Kubernetes. Let me back that up. Nginx maintains an ingress controller for Kubernetes called the Kubernetes Ingress. That's available at this GitHub repo that uses Nginx at its heart to do all of the routing. So that's kind of one of our areas where we work with Kubernetes. The other area that we just released at KubeCon this year is the Gateway Fabric, which is our implementation of the new Kubernetes Gateway API with Nginx at the heart. So in Mara, we have a good example of a pretty complex deployment of the ingress controller, which we'll get into in a little bit. But why we built this, I already got into who we are, and we have some opinions, so we thought we'd put them down. We also wanted to respond to, like, when we were searching for good examples of these type of reference architectures, a lot of the ones we found were either too simple to be useful, like they'd show one thing and then not show first layer of the onion, nothing else underneath. They might be really tightly coupled to a cloud provider, so they might be using like the cloud provider's unique language for standing something up and not something general purpose like Pulumi. Or they might require software that is licensed at thousands of dollars, and which leads me to our next reason, which is that we wanted to really highlight open source software as a basis for providing this modern application that is something that you'd like to use in production, and choosing things that are both free and have common interfaces to the rest of the ecosystem. And so the things that we are comprising Mara of is, we obviously have the infrastructure layer, so you can run it on various clouds. We've got management of things like SSL certificates, the infrastructure itself, the Pulumi, some of the Kubernetes elements like the ingress controller. We were very concentrated on observability, so we've got OpenTelemetry. The application is fully instrumented. We've got all of the accompanying visualization, and we were doing some continuous integration to make sure it was all working behind the scenes. So how can you interact with Mara? There's a number of ways, but the basic flow to get started is just like anything, clone the repo. You need to make sure that you've got a Pulumi account and an account with a cloud provider that you're going to use. In this case, we'll be using AWS. And we provide a setup script, and then after that, we'll run the Python startup script, which integrates with the automation API, and then hopefully you get it up and running. And once you have the code, so we will say that even though we wanted this to be sort of a production ready thing, we don't recommend that you actually run this in production. Don't base your startup on Mara, partially because we haven't run it in production. Like, we've run it, and tested it a lot, but we're not supporting an application on it. So, the best thing to do is to use it as a learning tool and as a reference. So you can stand up the whole thing, you can run it, you can click around, you can take a look at the stats and the metrics. And then you can say, okay, well, I want that in my project. Or maybe your boss or your client has said, hey, I really need to have an ingress controller that lives in my Amazon Elastic Container Registry. So you can go and take a look at, just similar to Pulumi AI, you can have a non-trivial example of that being set up. And then, take, if it's that 80% for you, take what you need and use it. So, this is kind of just like a basic, one of the things we were thinking about when we were writing Mara is, what would be the value to various roles? And so, as a developer, I can look at how the application integrates with a lot of the underlying cloud infrastructure and how that's all managed via infrastructure as code. Likewise, for the other roles, there are areas where you might find value. So I'm going to get a little bit more into what Josh was talking about with the automation API, because that was a really big turning point for us in putting together this complex project. So here's like a shot of my folder structure for Mara. And you'll see that it's kind of broken up into, Josh went over the concept of a Pulumi stack. Mara is made up of a lot of very granular Pulumi stacks. You'll see that, under infrastructure, I've got multiple cloud providers, and inside each cloud provider, I've got stacks. So if you look over on the right-hand side of the slide, you'll see ECR, Elastic Container Registry, EKS, Elastic Kubernetes Service, VPCs, and those are each Kubernetes stack that is a very modular implementation of standing up the VPCs, standing up your managed Kubernetes cluster, standing up the container registry. So how we managed that before was, like Josh said, we had all these stacks, and we basically had a big bash script that said, all right, we'll start with the VPC, let's call Pulumi up, and then wait for that to be done and go call Pulumi up again on the EKS thing. And there's an order that needs to be done in, right? EKS can't be stood up until you have the underlying compute there. You have the VPC all set up. So there's an order of these that needed to be maintained, and we were kind of maintaining it in a bit of an ad hoc way. So what the Pulumi automation API allows us to do is, like Josh said, flip the dependencies. So we wrote a pretty standard CLI tool in Python, takes arguments, that type of thing. So here we're invoking it with Python, and we're saying we're using AWS and the stack name is my stack, and bring it up. Here we can kind of encode those dependencies between the different modular elements of our infrastructure standup in code using programming models that you might be familiar with. So here's an example from the code, right? So we have this idea of a provider in Mara. So with Python, we found that it worked well to use an object-oriented approach. So we have a general idea of like a cloud provider, and underneath we've got like an AWS provider and like a DigitalOcean provider, a Linode provider. And for each of those, the infrastructure that you're going to stand up is going to be different, right? In DigitalOcean, you don't have the concept of a VPC that you need to stand up, as far as I know. Like you just stand up their managed Kubernetes and it's done. With AWS, you have a lot more to configure with the VPC underneath. So you have to have that done before you move on to Kubernetes. And so you can see here that we've got a standard, Python array that is encapsulating like, okay, VPC goes up first, managed Kubernetes second, Elastic Container Registry third. And we've got it wrapped up in a helper method that lets us call that information. And then once we get all that set up, on the Kubernetes side, once we get Kubernetes up, we're using Pulumi to deploy things into Kubernetes as well. And this is more general for any cloud provider that has a reasonably standard installation of Kubernetes that's managed. These are going to be the same. So we're going to be provisioning secrets, namespaces. We're going to be installing an ingress controller. So these things are kept at the superclass of the provider specific thing. But once again, just using an array that most people who have touched a programming language understand, we can understand the order of operations there. And then using the automation API, so this top one is the sort of the superclass, the base provider. And we just say, all right, those two helper methods that we had the infrastructure, and that's the cloud provider specific one. And then the common stuff, we're just going to mash them together, stand up the infrastructure first, then do the Kubernetes stuff. And then in the runner script, which is the closest thing in this project to just a plain Python script, we're just calling that. We're saying, all right, give us, for this cloud provider we've selected, give us the infra setup order and the Kubernetes stuff. And we're going to just loop over it and call up using the Pulumi API. And that'll give us a nice way to sort of aggregate different groups of stacks and pieces of deployment using the Kubernetes stack concept. So here's just an overview of what we're going to be deploying with AWS today, and just to give you an idea of how different it is for each. And under AWS, it's going to be VPC, EKS, ECR. With a different cloud provider, that's going to be different. And so this is kind of the general look at what we're going to be deploying, and we'll see that in a second. So the benefits of this approach, like I've kind of been saying, is that you get to normalize your patterns across multiple cloud providers. Supporting multiple cloud providers is hard. And so having an interface that is common for, stand up my infrastructure allows us to hide the complexity of the details of deploying similar infrastructure across, say, AWS and another cloud provider, and just work on like the orders. We have this explicit source of truth for the order of operations. That's really nice. That lets us have some certainty about the order in which things are happening, and kind of helps to reason about your infrastructure. And then it helps keep those modules really small. So if I switch over to my screen, let me see, make sure if I have the right thing up here. You can see that, I'll make this a little bigger. You can see that my VPC setup, I've got a lot more stuff. I'm not going to go over this code in detail, but I've got a lot more stuff going on. Subnets, I've got security groups. It's like a 300 line or a 100 line file here. But if I move over to my Elastic Container Registry, it's got 15 lines of Pulumi code in it to have us figure out how we want our Docker images to be stored in AWS. So it just goes to show that you can keep those modules super small, and even 100 lines isn't that much. So for all of the complexity that you have with cloud providers, being able to really encapsulate that stuff and hide the complexity is really helpful. I'll give you one more example of this kind of idea of creating consistent interfaces using general purpose programming languages. We have the Kubernetes ingress controller, and as we maintain it, we want to provide like a great example of both simple usage and advanced usage. And so we have the ability to just, you can just pull an image from Docker Hub and deploy it, and it'll work. And that has the most common setup. But if you're doing something a little more advanced, like you're using the paid Nginx Plus project, which is helpful for handling high load and very dynamic Kubernetes service structures behind the scenes, you will need to build your own Docker image to get this working. And then after that, you're going to have to push it up to some type of image repository, and that's going to look different between the different cloud providers. So we're able to use just like programming logic that you probably already know to take input. So we take input at that Python script level and say, all right, what's your source for the Kubernetes ingress controller? Are you going to build from source, or are you going to use the public registry? What version are you going to use? That type of stuff. And so we can just use simple programming logic. Okay, if we're compiling, then we've got a class that's going to handle all the complexities of compiling. That's like a 400-line class. Or if you're just pulling from the registry, that's 15 lines again. So, but on the outside, all you need to know is, okay, I'm using AWS. That's an argument that we took in our command line. And I'm just going to pull the right file to handle the push to the registry for AWS. And all I got to do is call push to container registry on it, and that'll be implemented differently for any container registry you happen to be using.
Javier, a quick question from the audience. So we have a question that is asking, how is testing being managed for these Python functions?
Testing being managed. So this is one area where I'm gonna have a little egg on my face, is that we don't have a lot of like traditional unit tests for that stuff. But as you said before, you could set up the same type of unit tests you might wind up with in a normal Python project.
For sure.
The integration of unit tests with the Pulumi code with the Pulumi specific functions is something that I don't know a lot about. Do you have comments on that piece?
Yeah, so I have not personally written unit tests so even as a practitioner, I do not generally see a gigantic amount of value in unit testing infrastructure as code per se. If you have functions that are behavioral in nature, then you should definitely test those using standard unit testing tools. But for your actual infrastructure, I would make the argument, and I think I may be in the minority here, that policy as code is testing the stuff that actually matters when it comes to infrastructure, right? Because the point isn't whether, for example, like, okay, if I enter this site or block, then it appears on my security group or whatever. The point is, like, is the infrastructure that I am deploying either correct or secure, right? But when it comes to like correct infrastructure, like let's say you're deploying a network, right? And you want to make sure that your application can talk to your database. There's no unit test that's going to be able to tell you that. You're going to actually have to provision the infrastructure for real in the cloud and test that connectivity that way. And there's no real tooling that makes that super easy. And there's also no easy way to simulate that locally. So forgive me for dropping an opinion bomb in here, but yes, I would say that like if you have like regular old Python code that is behavioral, that you should unit test, and you can unit test that using standard tools. But when it comes to your actual infrastructure, again, I would say, to summarize, use policy as code for that.
Thanks, Josh. So we're not using policy as code yet, because that's a newer feature that came out when we were not after we had kind of done the major development on Mara. To your point, though, we are unit testing stuff that is purely part of how we are doing things to then provide to Pulumi. So here's an example of a test that we have to test, your like taking the configuration you give to the CLI tool about the Docker image you want us to build and making sure that it puts together the right thing for you, which then serves as an input to Pulumi. And I'm not sure that, Josh, your opinion is that controversial to me either on the infrastructure side, although my experience there is probably more limited. So I'll refrain from having a strong one on it. But we definitely do have integration style tests that we run in our, sort of CI context to make sure everything came up properly. But since we're not supporting this in production, they're probably on the less rigorous side than if my neck was on the line for making sure that this all stayed up.
But by which I think you mean if you were on the other end of the pager.
That's right. And that's that would be a place where certainly I would be a lot more serious about that question. But you all, to your point though, the pieces of the parts that Pulumi lets you do is kind of mix the infrastructure as code stuff. And this is kind of what I'm getting at here with this piece is this is like programming, like structural stuff, right? Encapsulation of complexity, interfaces, all of this stuff is just programming stuff. And you can test that programming stuff in the same way that you would test normal programming stuff. And then the infrastructure, and it serves as inputs to that infrastructure as code stuff. And what you're getting out of those little balls of complexity is the simple thing that's easy to understand. And that takes the complexity of understanding how all of the pieces of your infrastructure fit together and makes that the thing you worry about instead of specifically how the image is getting built and that type of stuff. So yeah, let me just show you a quick, what it looks like to run Mara here. I've got it as a video because this actually takes about 40 minutes or so to run if you're actually running it against Kubernetes, AWS. And so it starts with cloning the repo. It does some Git submodules to pull in the Java application. That is a modified version of Google's Bank of Anthos project. We call it Bank of Sirius. Since we're using Python, we have a script to sort of handle all the Python dependencies and set up your virtual environment, which is something that you will definitely need to do with Python. We found that one of the biggest challenges of Mara has been how finicky Python dependencies are and how sensitive they are to things like your architecture of your system and what version of Python you're using and all that type of thing. So this is an area where a lot of people have trouble because a lot of systems are different. But once we've got that all set up, we just invoke the runner. So this is our custom written CLI tool. That's just a Python CLI script that uses the Pulumi automation package to do what I showed you. So it's saying, all right, provider AWS, bring up a stack called Mara Test 5, and then it'll walk you through some like AWS specific questions. So as you can see, it's asking you about what region you want to be in, what instance type you want to use, size of your EKS cluster, that type of thing. So this kind of walks you through. If you don't know what you need to stand this up, it gives you a bit of a handhold there. And also it lets you, here is just, we're asking for various passwords for the various databases and applications that are going to be stood up. So if you want to poke at that stuff, once everything is up, you'll know the password. And then this is just the Pulumi output, right? This is so you can see that we're kind of breaking it up with big rainbow colored headings. Oh yeah, I love poetry. I tried to convert this to poetry, ran into some issues, but poetry would be my approach. I'm not a Python person.
But man, does poetry make the experience a lot more pleasant.
Yeah, it makes it look like every other package management system. But yes, I totally agree that poetry would be the approach. So these are all the different, pieces, the small modular stacks that I was talking about earlier coming up. And you'll see the outputs at the end of each one. And that's a nice Pulumi thing where you're standing something up. And then if you define those outputs, they're not only available to other sort of stacks for us to go get, but it's great to just have that in the output. One time I was using it a lot as I was developing some of these updates from Mara that I'll talk about in a second is just knowing things like the EKS cluster name, because the minute you want to check stuff, you want to use K9S, which I'll show you in a second. You need to update your local kube config. And it's an easy command, but one of the things you need to know is your EKS cluster name, which I don't want to log into the AWS UI to find that out. It's nice to, have that spit out by the Pulumi process so that you can just copy that and be on your way. So it kind of just unfolds like this. It keeps going and it walks you through, what each step looks like, what the outputs were, what it created. If this is a new stand-up, but if it were you were doing Pulumi up again after making some changes, it would be showing you, what was updated, what was deleted, the standard infrastructure as code stuff. So I'm going to pause this and then jump into, actually what it looks like. So here I've got, this is running in AWS. I've got the Bank of Sirius application up. And this is a fake thing, so I can, deposit some money and just, show you that the thing works. I can send some money. The other things that we have set up that come with this are, a load testing thing. So if I set up, say I want 50 users hitting it, and I put in the host name that it spits out at the end, I can, have it start hitting the various APIs, and I can have access to things like Grafana to then take a look at, how my cluster is doing and that type of stuff. So this is when we're talking about the focus on, logs and telemetry and all that stuff, is that we have this all provided with you for you to sort of explore. And that's sort of the main thing that we want you to do. So that's kind of the overview of what Mara looks like running. One last thing I want to leave you with, and I don't know, Josh, if you have anything you want to jump in with before I jump into this, but I'm just going to talk about my experience. We've got a smaller team on Mara now, and so I had to do kind of an interesting update. And I think it's interesting to talk about. It's interesting to talk about how you build something, but it's even more interesting to talk about the experience dealing with it when you are under pressure and you need it to have it fixed. And so I'm going to go into that next. But I don't know, Josh, did you have anything you want to jump in with before I go that direction?
Oh man, I'm just so busy answering these wonderful questions from our audience.
All right, I will leave you with it, and if there's any for me, I'll tackle them once I'm done moving my lips. All right, so this is just going to be like a little story time. So as part of this, we made Mara, and then some of the original members that created Mara moved on to other roles in Nginx, and so I kind of came in afterwards, and so as a result, we haven't been like. It's a big job to keep one infrastructure up to date, as many of you may know who work at companies, keeping track of all of the Helm chart updates and Kubernetes version updates and all that type of stuff. And we've got 4 cloud providers that we've got in Mara. And so one of the things I discovered when I was chatting with Josh about talking to you all about this is, we've got Mara running on a version of Kubernetes in EKS that is no longer supported by EKS. So I was like, okay, well, if I'm going to show people this, I'm going to update it. So jumping into that, I ran into some problems. I found out that in the transition from Kubernetes 1.22 to 1.33 on EKS, they changed the way they dealt with storage, and our ELK stack, our Elasticsearch implementation, wants to dynamically provision volumes so that it can store.
Is that from when they moved storage, like what they call out of tree?
That's right. Yeah, they moved it to, they used to have let me see if I can pull it up. So I was going to show you kind of the elements that went into this problem solving. So they moved from having, I actually don't know what it was before, but basically you got your dynamic volume creation kind of for free when you set up an EKS cluster. But with Kubernetes 1.23 in EKS, they moved to requiring an add-on. So the Elastic Block Storage container storage interface add-on that you'll need to provide. And on top of adding that add-on, you've got some roles and policy stuff that you need to add in order to make it all work. So you need to not only install the add-on, but give it the power to dynamically provision storage when things do I'm forgetting Kubernetes has so many terms. It's a PVC. It's a volume claim.
Yes, persistent volume claim. Yes,
that's right.
So you need I believe you need a storage provider, right? Which is like, hey, I think that's what hooks it up to EBS.
Yep.
And then you need a persistent volume claim that's what your application wants.
Yep.
Which will then create a persistent volume.
Yep. And that's exactly what I found out by reading this. And so going into the, I found all the steps in like AWS CLI language. And so I figured out that what I needed an OIDC provider in my cluster, which is something that you can ask for when you provision the cluster, which we were not asking for before. I need to install this add-on for EBS to provide this container storage interface. And I needed all the policy stuff to go along with it. So when I was exploring this, I was looking at this here, and I was like, okay, this is fairly easy to understand, but I need this to happen in Pulumi. I am not an expert at Python, nor am I an expert in Pulumi. I've worked with it a good amount, but obviously probably don't match up to people like Josh. So I actually used the heck out of Pulumi AI. So I came in and I said, all right, I need EBS for my persistent volume claims, and it spit some stuff out, right? It spit out the type of actually this is not the one I was looking for, but this is the one I ended up using. So it wound up saying, okay, well, here's how you do the add-on install, and you're going to need a role here. So what I wound up doing, and I lost my instance of Pulumi Chat, but what I wound up doing is actually I prototyped what I needed to do using the AWS CLI to ensure that it worked. And then I fed this command into Pulumi AI. I was like, hey, Pulumi-ize this for me. And that was great. Like, and I could feed it a series of commands, and it spit out some code. And so I'll kind of walk you through. Josh, you look like you want to say something though before I
Yeah, yeah. I mean, that right there is like a perfect use case for Pulumi AI. Or like, let's say that you're like, oh God, all right, I wrote this IAM policy like 2 jobs ago. I don't remember the syntax for it, but I'll know the right thing when I see it. So like, I'll give you a concrete example. I like to put my secrets in configuration in SSM parameter store. And so like I was trying to write a policy that would give me access to read everything with this prefix. And like that was like a perfect use case for Pulumi AI. It's just like especially those things where you're like, well, I'll know it when I see it. That's really where Pulumi AI shines as well. So please, if you haven't used Pulumi AI yet, let's give it a roll. In fact, would it be all right if we want to roll dice?
do it.
Let's do it. Let's do it live, folks. All right, I am going to share a window. Hopefully it's the right one. Let me just there we go. Make sure that is the Pulumi AI. Okay, cool. All right, so you should now be seeing Pulumi AI on my screen. We will make it larger so folks in the audience. Yeah, so let's take Python. Show me how to build an EKS cluster and install the and allow me to provision EBS volumes as persistent volume claims, and then install the WordPress Helm chart. By the way, we have a new feature that's kind of cool that you can go between like a lot of explanation that explains like, hey, here's what the code does and here's what it is, and we're going to use these resources, or you can be like, hey, just the code. But I'm going to take the middle feature right here. So let's give this a go.
What's interesting is that I'm going to show you what I wound up getting out of where I wound up with. So we'll see how close it matches up. And you can tease me for my bad choices.
I would never.
But see it here. It's showing you the VPC, like all of this stuff that's encoded in Mara. It's showing it in one file. And so you can see in a more non-trivial thing how you might want to break those out in the modules. Okay, what do we got? What do we got here?
That is not exactly what I asked for. But hey, folks, this is what LLMs are like. Sometimes they're great, and sometimes the answer is not that great. And I might refresh this page and ask that very same question and get a very different answer. Yeah, so you can see here, it's just creating a VPC. That's not going to be that helpful because it doesn't include subnets. What it should be doing is using AWSX. So I can say like, hey, use the AWSX VPC component instead. And then go update. I'm not even going to get into the EBS volume stuff. Let's see. But like this is a great example, right? So like it gives you some feedback. Maybe it's not exactly what you want. That is now correct. I would have liked the rest of the program to be included with it, but again, LLMs are tricky. Yeah, but here you go. So that now corrected it. It actually used the AWSX VPC. So just for the folks in the audience, the difference. So if you use the AWS VPC, that is literally just the VPC. There's no subnets, there's no routes, there's no routing tables, any of that stuff. If you use the AWSX, so that's is like our higher level component library. AWSX is VPC. This would create public and private subnets across 3 availability zones. And there's a lot of options you can choose in that. There's a lot of options you can choose within that VPC. Be like, I only want a single NAT gateway or stuff like that. So I will stop sharing my screen.
Yeah, well, let me show you what I came up with. So I also used, obviously, like I said, I used Pulumi AI to ask very similar questions. And where I benefited is that it told me stuff I didn't know I needed, right? And so this is not something I needed the Pulumi AI to tell me, but this is just showing like the code changes I went through, like modifying something that I had. So this was false before. So I'm like, okay, I know from the AWS documentation I need to have an OIDC provider provision inside my EKS cluster. Let's change that to true. And then here's the part I got from the Pulumi AI, which it took me a little while to figure out. The Pulumi Python specific, working with sort of future values using outputs and how to interpolate them into a policy. So I had the policy suggestion from AWS, but how exactly to set that all up using the Pulumi syntax and Python, it helped me figuring out where I needed that Lambda and that applied to get that to pull some of the output that I'd gotten about my newly provisioned OIDC provider into some of the role the role that we would allow the add-on to assume. Now I need the policy, and luckily AWS has a policy for this. So I was just able to say, hey, Pulumi, connect this policy to this role, which is a pretty common operation. And then this is the piece that the AI also filled in for me is, okay, this is the right Pulumi module and, function to install it. And what are you going to need? You're going to need that role. And this is what's going to be in there in the output. So I was able to sort of taking in an arena that I didn't have a lot of pre-existing knowledge, but using a format that I'm comfortable with, which is just code. I was able to sort of get through it, learn the things I needed to learn, and had the AI there to show me the concepts that I didn't know. And that was really valuable for me. And what we wind up with is I forgot to hide this. What we wind up with is, something I can have a pull request. All of the stuff I just showed you goes into a pull request, and then I push it up to GitHub. And then I say to my teammate, Josh, Josh, tell me, does burping out this giant role trust policy make sense here? And he can give me stylistic comments. He can give me Pulumi comments. And so that's like the nice thing here is that this is a mode in which I'm really used to working. The way that this is set up allows that.
Yeah. And also, if you scroll up a little bit, here's a real simple example, but you can kind of see, so if you scroll down to line 102 on the right, notice here that hey, we're just using regular old Python. So we can use the regular old Python JSON library and use dump string, and it will just work if we want to serialize our JSON.
Yep. And once I get that out, I'm bad at Python, but even I know I can dot replace I need to strip off the HTTPS to get it in the right format. So it was a great collaboration between me and a unfeeling, unknowing, emotionless computer that helped me through something I wanted. Okay, so that is the end of my sort of content. I just want to fill you in on the future of Mara. It's just me now, and so the breadth of the project I think needs to come down a little bit. So we're probably going to be narrowing ourselves down. I can't be supporting Linode and all those other things. We're going to keep that code is all going to be there. Git history is forever. And so that'll all be there as a reference, which is one of the main ways we expect people to use Mara. And then, yeah, that's basically kind of where we're going. We're going to be kind of slimming it down a little bit, but prereqs, and it's a little janky. It's a little, but this is all in a pull request. I'm doing some final testing on it, but if you do want to test it out on AWS, I've annotated the pull request, and in the pull request description, it contains detailed information about running it. So give it a shot and tell me if I made a mistake. But yeah, that's all I had.
All right, folks.
Josh, you want to wrap up?
We are ready to wrap up. Thank you so much, by the way, for all the folks that are sticking around. We appreciate you spending your time with us, folks. This is what we call a call to action. So, if you liked what you saw today, there are 3 things I would like to ask you to do. 1, again, sign up for that Pulumi account if you have not done so. It's the easiest way to learn Pulumi, and it will, it's free for individual use forever. So there's really no downside to learning to use Pulumi with using Pulumi Cloud as your backend. 2, we have a Pulumi community Slack. You can join that at slack.pulumi.com. There are a ton of really, really engaged community members and Pulumi employees in the community Slack. There's a ton of channels. You can ask anything in there. If you're talking about Pulumi usage from like basic to advanced, you can ask questions about specific cloud architectures. Like, hey, I'm new to EKS and like, I think this is what I want to build, but like, is this actually right? Folks will be able to help you with questions like that. And you can even ask about things like CI/CD pipelines and automation, or even like DevOps culture things like, hey, how can I help push forward modern DevOps practices in my company? You can ask those types of questions as well. So do join the Pulumi community Slack. And then 3, if you have not yet done so, please try Pulumi AI. I think you're going to find that it's pretty darn useful. And also, like, if you're just trying to like explore, like, hey, what do like Pulumi programs look like? Pulumi AI is a great way to like get an idea of like what Pulumi kind of feels like from a developer's perspective. So with that, on behalf of myself and Javier, I would like to thank everyone for joining us. Again, folks, thanks for spending your time with us. We know that there are you have a lot of options out there for how you want to spend your time. We appreciate you spending it with us. Be well, everybody. So long until next time.
Thank
Bye-bye.
you.